What do you think? Can you see the benefits of aligning your learning activities to objectives? Working together in instructional teams to complete this process makes your job easier and validates the activity that you plan for your students. Take a look at this learning plan grid. We will reference it throughout this module and in others as well. It provides a structure for a team of teachers to differentiate learning activities among various modes of instruction: whole class instruction, independent work, small group work, and center-based activities and homework, according to leveled objectives. Let's talk about leveled objectives for just a minute. Of course, the teacher's goal is to get every student to mastery and beyond. But what do you do if the pretest reveals that some students aren't ready to tackle the target objective? Or what if some students are already demonstrating mastery of the target objective? In these cases, we level the target objective into prerequisite objectives, target objectives, or enhanced objectives. Leveled objectives are variations of the target objective and very much aligned to the target objective. A prerequisite objective is developed for students who require some foundational knowledge or skill before tackling the target objective. An enhanced objective is developed for students who are ready for higher learning. Once the objectives are leveled, assigning specific activities that support their attainment becomes easier. The activity instructions provide the detail that enables any teacher to use the learning activity and also become a means of explaining the activity to your students. We'll go into more detail on learning activities in Part 3 of this module, Differentiating Instruction. But before we move on, let's take a look at a classroom whose teacher differentiated activities among various modes of instruction by leveling the target objectives. Here, the teacher is working with a group of students who all demonstrated an understanding of the writing assignment. She is giving them instructions on enhanced learning activities. To the right, you will see a small group of students working independently on leveled activities to meet their needs. In the center of the classroom, you will notice a student who is working independently on a computer-based activity that is targeted specifically for her learning needs. In the back of the room, you will see two students working together. In this particular case, one student is sharing writing strategies with the other. And over here on this side of the room, we have yet another teacher-directed small group. These students demonstrated a need for further instruction on how to meet the activity's objectives. Now that we've developed objectives and assigned learning activities that align with the objectives, we need a way to assess mastery. Our next indicator speaks to that issue. Units of instruction include pre- and post-tests to assess student mastery of standards-based objectives. The pre-test and the post-test are the same test. The difference is in the timing of their administration. The pre-test is a quick assessment at the beginning of the unit or period of instruction to gauge each student's readiness for an objective and inform the need for leveled objectives and/or assignments. The pre-test is scored. The results, however, are not included in the student's overall grade. Here, we'll listen as teachers explain the importance of developing pre-tests.
Look at our unit plan, and we started to look at the standards and setting up what the different centers were going to look like. We realized, wait a minute, this pretest is not going to work. There were a number of times we had to revamp a pretest and give it again because we either didn't get the results that were, we didn't get enough results to really be able to put the kids into specific areas, or we felt that the pretest really didn't test what we wanted to find out with the standard. So the developing of the pretest, that's a big piece, and that takes a lot of time, and you need to make sure that it really aligns well with the standards.
The post-test is a way to get a read on students' mastery after the completion of the unit or after completion of the period of instruction allotted for the objective. The results of the post-test may be graded or included as part of larger graded tests. When instruction is aligned, teachers will have several other ways to determine mastery as well. Between the pre-test and the post-test, Students will complete a variety of learning activities and possibly other assessments. We're now ready to move on to the last two indicators of Part 2. Unit pre- and post-test results are reviewed by the instructional team. Instructional teams use student learning data to assess strengths and weaknesses of the curriculum and instructional strategies. Let's jump right in by seeing these indicators in action.
We started out first focusing on creating common assessments, making sure that they were standards-based. And believe it or not, that's a process. I mean, that isn't something that just, everyone is doing that. You might be surprised if you sit down with a test and go back and look, what objective does that really master? Is that test question mastering two or trying to get at 2 or 3 objectives, and then we're not sure what the student doesn't understand? All right, we're going to begin today's team meeting looking at our Unit 5 test results, which we gave our common assessment on about 2 weeks ago. And so if you could open up your spreadsheet to Unit 5, and we'll start going through each question, trying to identify the topics that we're going to include as review questions on our Unit 6 test, which is coming up next week. So we'll start off with question 1, and the concept here, total electrons, valence electrons. How'd we do? So our first task was to develop common assessments, and that probably took us maybe a year and a half, 2 years to really develop what we felt comfortable with common assessments. And then as we developed the common assessments, it then led us through to, okay, well, now that we have this data, this should be able to make our tests better. So that was our first strategy. Okay, let's make sure the test questions are testing what we want them to test, mastering a particular objective only, and really isolating it, and then revising questions that didn't do that either our students weren't successful on across the board, or the distractor provided us with some information as to where the misconception was. Linda, my data matched yours. My students did better on question 9 with that drawing as compared to question 13. I still had majority get 13 right, but not to the same extent.
Yeah, mine were really varied. I can't understand why. I mean, because I would think the distractor mine chose, was B. So they had the right number of valence electrons. They got their spin. They weren't in the same spin. So it's that little fine detail on Hund's rule where they spin the same direction.
There's a big difference between 9 and this one, in that there's an S and P. In this particular one, it refers only to the P.
Good point.
And that is probably why my kids did better the second time out, because they were able to focus on the P sublevel. And that made all the difference with the 3 orbitals. So there's going to be 1 in each.
Matt, what are you?
I think I just spent more time going over the rules and how to apply the rules, making sure that everything looks the right way, versus taking those rules and applying to identifying the element back in the periodic table.
I will say that I don't think I spent any time talking to them about up versus down when they're there alone.
Right.
So I don't think, for me, my students would have had any knowledge to choose C over B. Do you see what I mean? They're
But
the
yet
same.
Your kids did.
But they did. I don't know why, because I didn't spend any time. I spent the most time making sure they knew that those 2 electrons would be separate, not that they would both be spinning the same
As
direction.
I say, I think that's a real fine line. If I combine those 2 answers, my kids did very, very well.
Me too.
So they knew how things were spread out, but couldn't make that real fine detail choice in between the 2.
And then from there, the next progression was, okay, now we have tests that we feel pretty comfortable with. We still edit them. They are fluid because it depends on the instructional achievements we make. We then have to revamp and say, well, now they have this, but let's work more on that. Now we're really to the point where we're evaluating instructional methods, which is, okay, how did you teach the concept of stoichiometry? Did you use ratios? Did you use factor label? Did you use unit conversion? So we're really getting into those types of conversations. But again, it's been a long progression to that point. That isn't something that just happened instantly.
Do we all do dimensional analysis the same way? I know that you use it
Factor
where
label.
set up multiple things,
Steps.
multiple steps within
Right.
one problem,
One problem.
where I have my
Factor
students do
label.
3 independent problems for a 3-step equation.
Oh,
No,
so
I do
that
a
was...
one-on-one. That was
That
tough.
is probably why you're having more success at it than I am in particular.
Yeah, because they
mine
understand
is
one-step problems.
one-step problems,
So I just
right.
take that one-step problem and make them do one step, and one step, as opposed to bridging it all together.
Yeah. And my problems are bridged all together.
Mine too. Do
Mine
you think
too.
that would help with special ed if they did? Or do you already do that?
No, I do the one big problem, but I will try that. That sounds right.
That's fascinating. I think it'd be really interesting.
Yeah, I'm going to try that, Matthew.
Okay.
Because what I'm doing isn't working. It just isn't working. One big problem where I have everything set up and you just follow the steps through.
Well, maybe then we could do a compromise, since we could do that for a
One-step
one-step problem.
Exactly.
No
Right.
Because then
calculator answer.
then that matches what you're doing.
Yeah.
Right.
Definitely, and that could also not even be a review question. That could be used on a mole, because a mole conversion is already one step.
Yeah.
Right.
That is it. The problem is when you're doing mass, then you've got some headaches. That's the difficulty.
How do your students feel, Matt, when they're doing mass, and you're saying, okay, there's three
separate
steps? Do they have a hard time? You think that
They feel comfortable knowing that they're doing the same level of difficulty problem, but it's just longer.
okay.
They understand that it's not any more challenging, it's no more difficult. There's just 3 independent steps that they have to do.
Hold on, Matthew. We discussed this about doing the mathematical portion. How'd that work out? For
I
the
didn't-
same mass problem.
I didn't do it.
You didn't do it.
No.
Because there's a built-in error there, isn't it?
Well,
With the moles.
because my students are so weak in the math, I decided that it would probably be better not to show them the proportions,
Right.
so then they wouldn't have to think, when can I use a proportion and when can I not? Because I didn't want them using proportions if they're solving for molecules or volume. So if I have a student that's having a very, my stronger math students, I'll show them the proportions on the side. But for my weaker math students, I keep them with the same level of math every single time, so it doesn't get any more challenging for them. They don't have to remember the exceptions.
That's a lesson I need to learn then.
But I do think we need to remember that based on our results last year of our state assessment, our stoichiometry scores, our standard 4 scores, went up significantly over last year. And I think that's probably now being able to be attributed to 2 things. The first being the spiraling, where they're doing a little bit of stoichiometry, a little bit of unit conversion all the way through, and that catches most of the students. And then on top of that, possibly doing the 3-step that Matt's approach, doing 1 conversion for each problem. So we'll need to continue to fine-tune that, but I think we've made a lot of strides in Standard 4. I know you're still a little frustrated, Eugene, but I think we've definitely made strides based on our data that our Standard 4 scores have gone up.
As you've seen, a core part of an instructional team's work is the review of student learning data. Incorporating the review of unit pre- and post-test results as common team practice highlights early on where some students may require additional support or even enhancement. This data is also used to assess strengths and weaknesses of the curriculum and instructional strategies. Let's take a look.
The results are given to us where it shows us which students got the answers incorrect for each standard, as well as which answers they chose. And so what we do is we take that data and then we decide, is this a standard that we need to readdress as a whole group, if it's the majority of the class that missed it. If it's a few students that are struggling with that standard, we then know that they're going to need that support, maybe in a flexible reading group, or maybe just in the morning, just a quick intervention group, or in the afternoon. And so I guess we are going to be giving the test next week. And once we receive that data, we will be then making a decision together and also individually as to whether we need to go back and readdress things that have been taught, or if the students have mastered all the things that we've covered, if we can then go on to other standards.